Hi, this is Dr. M. Angaleshwari, Assistant Professor of Department of Mathematics, SRM Madurai College for Engineering and Technology. I am here to teach the topic Solution of Algebraic and Transcendental Equations. The content what we are going to see is Introduction, Algebraic Equation, Transcendental Equation, Fixed Point Iteration Method and Problem, and Newton-Raphson Method. Let me say what are the polynomial equations. The polynomial equations of degree greater than 4 are not solvable in analytical form. So we are going to solve these polynomial equations of degree greater than 4 by numerical methods to reach a solution to a correct possible desired accuracy. We come to know about a transcendental equation in engineering, and analytical methods do not exist for solving equations. So we are going to apply numerical techniques to solve algebraic equation as well as transcendental equations of degree greater than 4. First, let me say what is algebraic equation. An expression of the form f of x is equal to a naught x power n plus a1 x power n minus 1 till an, where f of x is a polynomial, where a naught, a1, an are constants and a naught not equal to 0 and n is a positive integer. It's called as a polynomial in x of degree n. The polynomial f of x is equal to 0 is called as an algebraic equation of degree n. And here certain examples are given for an algebraic equations. The algebraic equations are of the form x power 4 plus 3x squared plus 7x plus 8 equal to 0 and 2x cubed minus 3x minus 6 equal to 0. Now let me explain about transcendental equations. Equations which are not purely algebraic are called as transcendental equations. If f of x contains some function such as trigonometric function, logarithmic function, exponential function, then that function is said to be a transcendental equation. For example, 2x plus e power x minus 5 equal to 0 and 2x plus cos x plus 2 equal to 0 and log x equal to 0. Now let me say certain notes to be noted before entering into the sum. An equation f of x is equal to 0 is said to be algebraic if the equation is purely a polynomial in x. Every algebraic equation has at least one root, and an nth degree equation has exactly n roots, and the roots may be real, imaginary and complex. And the transcendental equation may have no roots or any number of roots. The roots of this equation may be real or may be imaginary. These are the hints we need to know before solving the equations. What is meant by the roots of the equation? If f of x is equal to 0 be an equation and alpha is a value of x such that f of alpha equal to 0, then alpha is said to be the root of the equation f of x equal to 0. For example, let me take a quadratic equation x squared minus 5x plus 6 is equal to 0. Here 2 and 3 are the roots of the equation. Okay, now we are going to use a numerical methods to solve these algebraic equation and transcendental equations. The method of finding accurate roots. The following computer-oriented methods are used to find an accurate real roots of the equation f of x is equal to 0. That is Bolzano method of iteration, method of regular falsi, secant method, method of direct iteration or method of fixed point method, and Newton-Raphson method. The above methods are used to solve the algebraic equations as well as transcendental equations. The basic properties of an equation should be: if a polynomial of degree n vanishes for more than n values of x, then it must be identically 0. Every equation of odd degree has at least one real root. If f of x is continuous in the interval a comma b and f of a and f of b have different signs, then the equation has at least one root between x is equal to a and x is equal to b. We need to know about the Descartes rule of the set. An equation f of x is equal to 0 cannot have more number of positive roots. Then there are change in signs in terms of polynomial f of x. An equation f of x equal to 0 cannot have more number of negative roots. Then there are change in the signs in terms of polynomial f of minus x. First, we are going to solve a numerical method. We are going to solve an algebraic equation or transcendental equation by a method of fixed point theorem. Let me first introduce the statement of fixed point theorem. This method is known as fixed point iteration. We call it as x is equal to g of x. It's a very useful method to get the root of f of x is equal to 0. Suppose we want the approximate root of the equation. Rearrange f of x into an equivalent form x is equal to g of x. Assume that x naught be the starting approximate value of the actual root. That is f of r equal to 0. With this assumption, we are going to start the problem. Setting x is equal to x naught in the right hand side of 1, we get the first approximation. Again, setting x is equal to x1 on the other hand, we get the successive approximations x2, x3 until xn. The sequence of the approximation roots x1, x2, xn. If it converges to R, it is said to be the root of the equation f of x. Whenever we have x power t equal to g of xt is called a fixed point theorem, fixed point for the function g of x. Note, the convergence of the sequence is not Gaussian always unless the choice of x naught is properly chosen. So next we need to know what is convergence of a sequence of the sum. The condition for the convergence of the method. First, let f of x be the equations. The actual root is R. The equation can be written as x is equal to g of x. Let 1 be the interval containing the root x is equal to R. If cardinality of g dash of x less than 1 for all x in that particular interval, then the sequence of the approximation x naught, x1, xn will converge to R. If the initial starting value of x naught is chosen in 1, not 1. Since cardinality of xn minus r less than k cardinality of xn minus r, where k is a constant, then the convergence is linear and the convergence is of order 1. The sufficient condition for the convergence which used to check in the problem is cardinality of g dash of x should be less than 1 for all x in I. And this is the condition which we are going to check in the problem. Let me give an example problem. Find the smallest positive root of 3x equal to root of 1 plus sin x, correct to 3 decimal places by an iterative method. That is, we are going to solve this problem by an fixed point method. To solve this method, we need to know whether the given equation is an algebraic equation or transcendental equation. By observing, we can determine that the given equation is a transcendental equation. The given equation is 3x equal to 1 plus 1 plus root sin x. Let me take f of x is equal to 3 power x minus root of 1 plus sin x. Let me take an initial value of f of 0. If I substitute the value of 0 in that above equation, f of 0 value is negative. And now let me apply f of 1. While I apply f of 1, let f of x is equal to 3x minus root of 1 plus sin x. Now let me apply f of 0. If I apply f of 0, the value is negative, and if I apply f of 1, the value is 3 into 1 minus root of 1 plus sin x. 1 plus sine of 1. 3 minus root of 1 plus the sine of 1. We have to use an scientific calculator, and the value of sine 1 is 1.84. Now 3 minus root of 1.841. So the value is 3 minus root of 1.841 is 1.357. So what's the value I arrived as? A positive value when I substitute f of 1. So that is a variation from 0 to 1. If I apply 0, it is a negative value, and if I apply 1, it is a positive value. So there is a variation from negative to positive. So let me conclude that the root lies between 0 and 1. If there is a change from negative to positive as well as positive to negative, the root lies between these areas. Now the root lies between 0 and 1. We take g of x is equal to, that is, I'm going to determine a value of x. Now from the given equation, let me take g of x. G of x is nothing but the value of x. Value of x is equal to 1 by 3 root of 1 plus sin x. Now g dash of x. G dash of x x's, we are going to differentiate that. While we are differentiating, we arrive with a value of 1 by 3 into 1 by 2, 1 plus sine x minus 1 by 2 into, after I have to differentiate the whole part of root of 1 plus sine x, I have to differentiate the sine x inside. So after, I will derive with a value of cos x. Now after substituting everything, I will get, evaluating everything, I used to get 1 by 6 cos x by root of 1 plus sin x. Since the value here is 1 plus sin x, the whole power minus 1 by 2. So I can write it in the denominator value. Now the g dash value is 1 by 6 cos x by root of 1 plus sin x. Now let me check the convergence test is applicable. Let me check with an 0. Cardinality of g dash of 0 equal to 1 by 6. Cos 0 we know the value is 1 and root of 1 plus sin 0 is 0 and 1. So the value is 1 by 6 which is less than 1. Now let me check with 1. Substituting the value for g dash of 1 equal to 1 by 6 cos 1 by root of 1 plus sin 1. And we have to use the scientific calculators, and cos 1 value is 0.54 by 6 into root of 1 plus sin 1 value is 0.842. After doing simplification, we arrive with a value of 0.066, which is again less than 1. So the convergence test is satisfied now. Now what we are going to do is, we are going to take an value between 0 and 1. That is why we have said that the root lies between 0 and 1. So let me assume some value x naught between 0 and 1, and let me find out the root of the given equation. We know that cardinality of g dash of x in the interval 0 and 1, it is less than 1. So let me assume the value, let x naught equal to 0.4. Now what we are going to do is, we are going to substitute that x naught value in my x. That is, let me take, I'm going to find out a successive approximation. Successive approximation, what I'm going to do is, first I'm going to find out the value of x1. x1 is nothing but 1 by 3 root of 1 plus sine x naught. In the place of x naught, I'm going to substitute the value x naught equal to 0.4. I am repeating that, let x naught equal to 0.4. I am just in random basis. I am in error and trial basis. I am taking from the interval 0 and 1. Since in between 0 and 1 interval, the convergence is satisfied. So now let me take x naught equal to 0.4 and 1 by 3 root of 1 plus sine 0.4. Now I'm going to show you how to find the value using a scientific calculator. Sine, whenever we are using the values to find, we have to be very careful in using the brackets. So now sine 0.4 is 0.393894. After decimal point, we have to take 3 values. Now I am going to just substitute the value, the whole equation, 1 divided by 3 equal to 0.333. Now I'm going to find that overall equations value, that is 1 divided by 3 is 0.333 into root of 1 plus 0.39. The value is 0.3926. So while I am applying x naught equal to 0.4, my x1 value arrives with 0.3926. After decimal point, I am going to take 3 digits. So at the fourth, if the fourth digit is greater than 5, we have to add 1 to the nearest digit. So the value becomes 0.393. Now, at deriving the value of x1 equal to 0.393, I am going to determine the value x2 by substituting the value of x1. x2 equal to 1 by 3 root of 1 plus sine. I have to substitute the value of x1 here, but sine 0.393. Again, I am going to use the scientific calculator to determine the value of sine 0.393 as well as 1 by 3 and the overall value using scientific calculator. Sine 0.393 I have determined the value of sine 0.393. Next, I have to find the value of 1 divided by 3. Into root of 1 plus sine. A sine value I have arrived with 0.3829. So I am rounding off to 0.393. So the overall value is 0.39200. This is the value which I have arrived for x2. Now the value of x2 is 0.392. Let me go with a value of x3. Before that, we have to be very clear in checking with the previous root values. Like x naught equal to 0.4. What is x1, x2? Now I'm going to substitute x2 and I'm going to find out the value of x3. Now 1 by 3 root of 1 plus sine 0.392. So now I have to find sine value 392 is this, and I'm going to check with the overall value. You have to be very precautionate in checking that whether your scientific calculator is in a radian form. Now I'm going to solve for the overall equation 1 divided by 3 root of 1 plus that sine 0.392 value is 0.3820. So I'm going to substitute the value. Now the value is 0.3918. We are going to round off till 3 digits. So I'm rounding off to a value of 0.392. So x3 value is 0.392 and the value what we have arrived for x2 is also 0.392, which says that the value of x2 and x3 are similar. So we can conclude that now I'm rounding off here to 392. And we have arrived with the value of x2 is also 0.392. Now let me conclude that the value of x2 and x3 are equal. That is, the value is 0.392. Hence, Hence, the root of the given transcendental equation is 0.392. This method is known as fixed point iteration method. And with help of this method, we used to find out the roots of the algebraic equation as well as transcendental equations. Thank you.